Welcome students to the lecture on heat transfer. Now in this lecture I am going to teach you the various methods of heat transfer. But before that, let me ask you a simple question. What is heat? Or what is the nature of heat? So I hope most of you have this answer in mind. Heat is a form of energy. That's right. But previously there were two schools of thought regarding the nature of heat. There is one caloric theory of heat which says that heat is a physical entity like liquid. The reasoning is liquids flow from high pressure surface to low pressure region. Similarly, heat flows from high temperature surface to low temperature surface. So the logic is okay. But then there is a different school of thought called dynamical theory of heat, according to which heat is a form of energy that arises due to the mechanical motion of material particles. Now, this theory was supported by a number of experimental observations by Rumford, Davy and Joule. Then there came kinetic theory of matter, which was initially developed by Bernoulli, and later in 19th century Maxwell gave a solid mathematical basis for that, which finally came in favor of the dynamical theory of heat. So today we believe heat is a form of energy. Now in this lecture I am going to discuss the various methods of heat transfer. Stay tuned, enjoy the lecture. So, as we just learnt, heat is a form of energy intimately connected with motion in matter. According to Joule, a given amount of work always produced same quantity of heat in all cases, so that W by H is equal to J, a constant called mechanical equivalent of heat or Joule's constant. So, heat is a form of energy like mechanical work. We use sensation of touch to find whether a body is hot or cold. Remember, temperature is the measure of heat. Now, let us move to the discussion on the various modes of heat transfer. So we have three different modes of heat transfer: conduction, convection and radiation. You see in this example, I am trying to heat or boil some water using a tumbler like this. So now heat gets conducted from one part of this holder to the other via conduction. Conduction is the transfer of heat from one substance to another by direct contact. Whereas when you consider this water molecules here, the molecules down below, they boil first and then they rise up, and the colder water molecules, they come down. So there is a transfer of matter. So convection is the transfer of heat through a fluid caused by molecular motion. Now imagine some person standing nearby. He'll feel some heat. That is due to the radiation. Energy that is radiated or transmitted in the form of rays or waves or particles is what we call thermal radiation. Now let us discuss in detail about conduction. According to Maxwell, conduction is defined as flow of heat through an unequally heated body from places of higher temperature to the places of lower temperature. Now, in this kind of heat propagation, although the material takes an active part, there is no visible movement of the material itself. Let us consider a solid being heated like this, a solid rod being heated like this. So the heat is transferred from one end of the rod to the other end. Now this happens due to molecular vibrations. Remember, conduction takes place in solids and fluids, but with varying degree. The heat spreads through the body by molecular vibrations. Now, good electrical conductors are also good thermal conductors. So metals being good electrical conductors, they are also good thermal conductors. Feather, fur, natural fibers are all examples of natural insulators or the bad conductors of heat. These materials allows birds, mammals and human beings to stay warm. In winter, we wear woolen clothes. These woolen clothes have a number of air pockets, as you see here in the close-up diagram. There are a number of air pockets where air is trapped. Air is a bad conductor of heat. So there won't be any conduction of heat from the body to the surroundings. So the body retains its heat. Now you see sea otters, for example, they live in ocean waters that are often very cold. So they have a thick fur called blubber, which keep them warm. Even sea mammals like sea lions, whales, penguins, they all rely on thick layers of fat, as I said, called blubber, which is a very poor conductor of heat, to prevent any loss of heat through their skin. Same logic is applied to insulating homes or buildings. Now in these cases, methods involve either trapped air pockets between walls, the fiberglass which traps air within it, or high density foam, as you see in these pictures. The other good example of conduction. Spacecrafts are a special case. They use insulation in the form of foam or reinforced carbon composite material, as you see here, and the silica fiber tiles. Now this is the nose portion of the spacecraft Discovery, used by NASA in many of its operations. All these are poor conductors of heat and therefore prevent heat from being lost in the space and also prevent the extreme temperatures caused by atmospheric re-entry from entering the crew cabin. So the astronauts inside the spaceship, they are protected from high temperatures with these carbon tiles. Now let us move into the next mode of heat transfer, convection. Maxwell defined it as the motion of the hot body itself carrying heat with it. As a best example, let us try to boil some water in a tea kettle. So initially the water molecules at the bottom of the kettle, they warm up, and these warm molecules being less denser, they float up, and now the cold molecules in the upper portion, being denser, they sink down like this. So gradually the entire water gets heated up in this process of convection. So Maxwell defined it as the motion of a hot body itself carrying heat with it. Now the power of transmitting heat in this way by actual motion of heated particles is exhibited by liquids and gases. Another good example of convection. By heating the air inside the balloon with the burner, it becomes lighter than the cooler air on the outside. Now this causes the balloon to float upwards. Remember, warm air always rises up. The other best example for convection is ocean winds or trade winds. These are due to convection. As you see here in this first figure, during the daytime, usually in summer, the land gets warmer faster than the sea water. So as the land heats up, the air above it begins to rise, forming a low pressure area near the land. Then cool air situated in the high pressure area spreads across the water and moves in over the land. So during daytime, the people near the seashore, they experience a cool breeze from the sea due to convection. Now during night, the land quickly loses its heat while the water retains its warmth. This means the air over the water is warmer, less dense, and begins to rise. Cold and dense air over the land begins to move to the water surface. These are the best examples of the natural convection. The third mode of heat transfer is radiation. Now we receive a lot of heat energy from sun. Now in between sun and earth there is a lot of space. Still we are able to receive the heat energy via electromagnetic waves. This is called thermal radiation. So Maxwell defined radiation as the hotter body loses heat and colder body receives heat by means of a process occurring in the intervening medium, which does not itself thereby become hot. Heat is transferred via electromagnetic waves arising from periodic motion of charges at the source of radiation. It depends on the nature and the temperature of the radiating source. Radiation takes place even in vacuum. Thermal radiation is identical to the light as it exhibits reflection, refraction, interference, diffraction, polarization, etc. So just like light, radiation is also an electromagnetic wave. You can see here, when we are near a campfire, we get the warmth via this electromagnetic radiation. Now we see another important application of thermal radiation. All bodies radiate heat. So now you can see most of this heat energy in infrared region of electromagnetic spectrum. And the infrared radiation emitted by all the bodies is a function of temperature. So there is a special camera which can detect this radiation in a way similar to the ordinary camera that detects visible light. Now this is what we call thermography. So even if the body is in the dark, still it radiates heat. And now this heat can be captured, or this infrared radiation can be captured with this special cameras. We call this process as thermal imaging. You see in this thermal image to your left, there is a boy eating some ice cream. Now there is some heat energy radiated from every part of his body, and you see this head portion emitting more heat energy than the other parts. Of course, there are wavelength specifications, but we are not going deep into the subject of thermal imaging, remember. So now you can see the heat radiated by various parts of this body in this thermal image. Now fortunately we have this non-contact infrared thermometer. You need not even touch the person's body having fever. One of the most useful gadgets in this corona time. So without contacting the body, we can record the temperature of the body with this infrared thermometer. Now you see in this video, there is a giant Japanese hornet which will prey on honeybees. Now, how do the honeybees fight? Carefully watch this interesting video. This is the hornet. Feeding on the honeybees. What do the honeybees do? All the honeybees swarm the hornet and begin vibrating, raising their collective temperature to 117 degrees Fahrenheit, so nearly 47.2 degrees centigrade, and turning their crust of bodies into somewhat of a convection oven. See the thermal image of that. While the honeybees can tolerate temperatures of 118 degrees Fahrenheit, 47.8 degrees centigrade, Japanese giant hornets can only tolerate 115 degrees, that's 46.1 degrees centigrade. So gets burnt away, unable to withstand the heat. Survival of the fittest. The Darwin's theory works here. Students, this is the end of our lecture 1, and in this lecture we learned all the 3 modes of heat transfer, and we tried to understand them with some very good examples. Thank you.